What is up, guys? Bringing you guys another video here where we're going to be talking about rebuilding a pump and the steps I go through to, one, decide what was the motor failure, what caused it, what materials are at our disposal, and what we can do to protect it long term and make sure we get the most out of that repair. Now, the first question for me when I'm looking at this is what caused this pump to fail, or what caused the localized failure. Maybe the whole pump didn't fail, but what caused this, so that we can assess what the actual root cause is and then address that with our repair. So within the what caused this category, we have three main things that can cause a issue with these pumps. And the first one is going to be corrosion. And the reason I have this separate from chemical attack, although chemical attack can go under corrosion, is when I say corrosion, I generally just mean something that's atmospheric or moisture based, whereas chemical attack is more directly like, hey, we had something alkaline in there or acidic in there and it was eating away at the substrate or the piece of equipment itself, and that's kind of where I delineate. The third one being abrasion, which we've talked about at length on this channel, which is just generally speaking abrasion, wear, erosion, any of those three that are causing that material to be worn away, something super abrasive. That is what that issue is. Now, when we're rebuilding a pump, we have three materials that are at our disposal here. Now, within each of these, there are obviously, sub grades here, where within a paste grade we can have a number of different paste grades. Within a brush grade we can have a number of different brush grade materials. But for us, there's three main categories, and that is going to be, one, the machinable coatings, and this is what we're going to use when we're going back to tolerance. The second being the paste grades, where we need to build up very quickly, and this can also be a machinable. And third being our brush grade materials, which are designed for that top coat, that super smooth finish that we're all used to seeing when we rebuild a pump. Now, I like to break down a pump into two different sections, the first one being the pump casing, the second one being the impeller, because these, while similar in what repair we're going to do, can be different depending on what is going on with each. So jumping into the pump casing first, the first question I like to ask is, hey, do we have any tolerances to deal with? And when we're rebuilding these, if we don't have any tolerances, or here the don't machine, that's where I'll typically, or in most cases, use a paste grade ceramic, because we can build quickly, and because we don't need to machine it back, we get all the properties of a ceramic coating in one go. Now, on the flip side, if we are dealing with some tolerances or some areas that need to meet up or mate up very well, then we'll go with the machine grade system there. That way we can finish it how we like it, and it won't pose a problem further down in the repair when we get to the end and then we have an issue. We can solve that from the beginning. Now, within the resurfacing here, so we have two different things. Generally speaking, once we're resurfacing, we're not going to be doing any machining, because this is going to be a less intensive repair. In some cases, we may not have to do any rebuilding and it's just straight to resurfacing. But in most all cases, once we get to that resurfacing step, then it's just a matter of how much material do we want to put down. And for me, I look at that as, first, we want to do a brush grade, because in most cases we do have some tolerances to work with, but in some cases, in certain areas, they may say this is a high wear area and we don't have any tolerances to worry about. With that, I will just go straight to the paste grade material, because that will allow us to build more, which in terms of abrasion will just give us more wear resistance. Now, we're going to run through the same two slides and just replace the word casing with the impeller. Now, with this though, this is going to be much more critical, because these materials are spinning, the impeller's spinning. We do have some balancing things to worry about. So generally speaking, when we're working here, I almost always opt for a machinable on the rebuild side, so that we can make sure that surface is perfect before we top coat. In some cases, they can say, hey, it's real low speed, we don't have to worry about it, and we can put more material on, where we'll go with the non-machinable or the ceramic version. But for me, I like to stick with the machine grade systems here, so we can make sure that impeller doesn't cause any issues. Same rules here on the resurface side, with the exceptions of the paste being similar to the machinable systems here, I'm more hesitant to go with any higher build systems on this unless the pitting was so bad and we're building back so much that we need it. I will generally opt for only a brush grade because it's not really going to affect the balancing too much. Now, real high velocity stuff, we will have those issues, but generally we're going to switch to a metallized coating for that, which is not something I do, but they're very good systems. But where that velocity isn't necessarily an issue, the brush grades are great. We can keep them thin, 10, 15, 20 mils, get our wear resistance, get our corrosion resistance, and from there, we're off to the races. Now, these next slides are going to be basically a rework of the first slides I just did, but just coming in from a different angle. And that just starts with how do I get the most out of the repair, either from a efficiency standpoint or from a longevity standpoint. And these slides are going to dive into that. So the first one here, the quickest way to ruin this would to be put in something that we cannot machine back in a high tolerance zone, and then we have a big issue and we end up breaking the system all over again. So the first thing that I'm worried about is tolerance control. And that really just comes down to, do we have any tolerance issues or do we not? If we do, machinable all day. If we don't, we still might go with that just for cleanliness and keeping things good, but not necessarily. Following that is understanding what is actually going through the pump and matching the resin to that, specifically with chemical resistance. With corrosion control, we have less of an issue because most all epoxies are going to be good for just general corrosion, like think water. But if we're dealing with anything alkaline or acidic or anything like that, I will then generally opt for a better resin system. It doesn't necessarily have to be a Novolac, which I talk about as being a buzzword, but I will opt for a better resin system, either with a better fill package or just more compatible with that, so we don't have any issues here. Now, a common theme on this channel is talking about abrasion, and with that, what we're looking to assess is how aggressive of an application is it. Sometimes they can say, hey, that system's abrasive, but it might be abrasive over the course of 3 years, and some systems might be abrasive over the course of 3 weeks or months, where it's much more aggressive. And so with that, what we'll do is we'll swap both the resin around. Depending on what that system's doing, we may opt for a harder or a more mechanically strong resin. Pair that with different grades of ceramic, which we can step up from a aluminum oxide into perhaps a carbide. There's some different things that we can tune there within that system, and that's how we'll decide. And lastly, kind of looping everything together, temperature is kind of the great equalizer in this. If we're not operating at real high temperatures, everything else that I just stated will hold true for the most part. Now, as temperature starts to increase more than decrease, as it starts to increase, we can run into issues with the resin softening, which from a corrosion standpoint might not necessarily be an issue, but if there's any abrasion whatsoever, that can cause a bigger problem because we're weakening that resin and the ability to hold the ceramic in that's designed to resist that abrasion. So as temperature goes up, that's where we'll switch that resin again, maybe switch over to a Novolac or something better geared for that higher temperature and can also resist everything else we just discussed. And a big thing here is that temperature, when it increases, is that a steady increase and it stays up there, or is that fluctuating quite a bit? Because that can also cause issues with the resin where it's going hot, cold really fast, and we'll start to see some failures. So these are all the things that I account for when I'm looking at a system and deciding on what to put forward. And lastly, my forever talk, which is there is no best. Even with these systems, what might be good for one pump might not necessarily be good for another, and so that's where we go through these evaluation steps to make sure that what you are looking to achieve, we can achieve with a resin, and not necessarily the resin that I gave the last guy. It could be a different resin so that it's better suited for what you are trying to do. Appreciate you guys. Take care. Godspeed.